back and listen to it. Yeah, okay, so we're recording. Okay, get rid of that. So I got 3 pieces. So let's look at the piece on the far left. Joanna is not here. So Angie, what kind of a function is this? Do you recognize it?
I don't. It's not a constant, but.
No, constant means horizontal.
I don't know what type it is.
So, does it look like a line? It's a linear function. All right. So let's actually make a connection here, a visual connection. Line, linear. Right? I just add an AR and it becomes linear. This is a linear function. So again, Angie, I'm going to ask you if you're unclear, just say so. Do you remember what is the formula for a linear function?
I'm not sure. Is it y equals mx plus b?
One more time, y equals what?
Mx plus b.
That's right. That linear functions, y equals mx plus b. Okay, so hang on. Let's see. We'll get somebody else to help us with this here too. Oh, Helena, again, you get to help me. What is the m in the y equals mx plus b?
It's the slope.
And did you get a slope for this line here?
Yeah, I got 3.
Oh, you're very close.
3/1.
Well, is it a positive slope or a negative slope?
It's negative.
Negative slope, right? Remember, negative is going downhill, positive is going uphill. So, all right, so I have a slope of -3, so -3x. And did you get a b for this one, Helena?
No, because it doesn't go intercept the y-axis.
Oh, okay, so I'm really glad you said that, because you're right. This line doesn't intersect the y-axis, but if it did intersect the y-axis, and that's the way we need to look at this, if it did intersect the y-axis, what would it do? Let's take a look. Let's see. It's going to go down 3, so it's going to go, wait. 1, 2, 3, yeah, okay. So if I extended this function, where would it intersect the y-axis? Can you see it?
-2.
Very good, okay. So the equation of this line is y equals -3x minus 2. Is everybody's got to be clear on that. I know that my piece doesn't intersect the y-axis, but if I'm defining the equation of the line, and I'm using y equals mx plus b, I gotta have I gotta find out where it would have intersected the y-axis. Esme.
How is the line negative if it's going up?
Oh, really good question also. You're seeing it's going up because it's starting down here and the arrow is going up like that, right? Yeah. So when we're talking about slope, we're talking about, let's actually do a little a separate picture here. Okay. So when I'm talking about slope, let's make an XY axis. I'm sorry it's dotted, but we can live with it. There we go, XY axis. And let's make a line. I'm going to make a line. Properties. Solid line, blanket black. Okay, so 2, 2, 2, 2. Okay, so here is a line. And when I'm talking about slope, I'm doing what we write it, we write delta y over delta x. The change in y over the change in x. Okay, so you might remember it as like y2 minus y1 over x2 minus x1. Do you remember that? Great. So let's take a look at it. I'm always reading from left to right, just like when I'm reading a book, I'm reading from left to right. And so if I'm reading from left to right, this line is going down from left to right. Can you see that? Are you just saying yes, or do you mean yes?
Yeah.
Okay, so let's look at it with numbers, right? So here's 1 point on this line, which is the point -1, 3. So -1, comma 3. And here's another point on this line right here, which is a point +1, -1. So let's call this P1 and let's call this P2. So Y2 would be -1 minus +3. Do you see where I'm getting that from? My Y2 is -1 and my Y1 is +3. Yeah, so the change goes from Y2 to Y1, and that is divided by X2, which is 1, minus -1. So that gives me -4 over 2, gives me a slope of -2. So one way to tell the slope is looking at it from left to right, which direction is the line going? If it's going down, it's negative. If it's going up, it's positive. And the other way to tell it is just to pick a couple points and work the algebra. Everybody okay with that? A little refresher on slope. Just so you know, if you're going to take calculus next year, or if you're going to take calculus in college, there's two sides of calculus. There is differential calculus, which is what I spend most of the time on in calculus, regular calculus, and then there's integral calculus. And differential calculus, it's all about slope, which is amazing. That we're going back to like linear functions and slope, and it's calculus. It's all about slope. So slope is like super important. All right, so we got that. So we got the equation of that line, and Sienna, you're there. Okay, can you help me? Let's ignore where I extended this line right here. I'm going to delete that. What is the domain of this piece of the function? Can you tell?
No.
Okay, so you see you see the piece of the function that I'm looking at right here, right?
Yeah.
And you see that it's going to go up and up forever, right?
Yeah.
And if it's going up forever, it's also going to the left forever. Can you see that?
Yes.
So then what is the lowest x value for this piece?
-1.
Nope, -1 is the highest x value. I'm going to go lower on the x scale. So what is the lowest x value for this piece?
-2.
Nope, I go beyond. Here's -2. My function goes beyond -2, doesn't it?
The -3.
Well, if there's an arrow here, it's going to keep going beyond -3, isn't it?
Yeah.
Where's it going to end?
I don't know.
Well, does the arrow mean it ever ends?
Yes.
No. So the arrow means it's never going to end. Means it just goes on forever. So the lowest x value on this piece here is -infinity. And then Sienna, what is the highest x value of this piece here?
-1.
-1. And is -1 included?
Yes.
Open circle, no. Are you with me?
Yeah.
Are you sure?
Yeah.
So you're gonna ask me questions if you have questions, all right?
Okay.
Next piece. Next piece. Camila, what did you get for this piece here?
What do you mean by that?
So what is what kind of a function is this piece right here?
This is a constant function, right?
It's a constant function. And so that would be y equals what?
I have -2.
That's what I have also,
Okay.
right? So y equals -2. That's all this piece is. Y equals -2. F of x equals -2. So what is the domain of this piece? Did you get that, Camila?
Yes.
What did you get?
I have, or of this, or like if you would expand it.
Well, now, the only reason I expand the function is to find out, is to define the function. Like, for example, in the first one, we had to expand it to find out what the y-intercept was. Are you with me? But this one here, you've already got what the function is. It's y equals -2. So I just want the domain for the piece.
So then would that be -1 to 2?
It would be -1 to 2. And that's
With
exactly
brackets
what it would be.
on both sides.
That's right. Brackets on both sides. You're absolutely right. I was going to put parentheses. So -1 to 2. This piece goes from x equals -1 to x equals 2. That's as far as it goes. Questions on that piece? Please speak up. Everybody's good? Okay, let's look at the last piece. The last piece. So Angie again, oh, now Angie, this is good because we did the last one. What kind of a function is this last piece right here?
Also linear.
And it's a linear function. So y equals mx plus b, right? Can you tell me what the slope of this is?
2.
Yeah, the slope is +2. I go up 2 over 1, up 2 over 1. So the slope is 2. So I have, it's a different color. I have 2x. And let's extend this guy here. I'm telling you that this particular line is a guy. I don't know why, but I'm just saying that. All right. So let's extend this one here. So 2, 2, 2, 2. What is the y-intercept of this line?
Is it -4?
It is -4. Yeah, there we go. We're all over this now. So this line here is 2x minus 4. Is everybody okay with that?
I have a question about
Great,
that.
please.
Like for mine, I don't know if I didn't draw it like to scale or something, but like I see it on the like on your graph how it's -4, but I don't really get how to get that like when I'm drawing it.
Ah, good. Okay, so that's really good. So first of all, are you using graph paper?
Yeah.
Oh, that's good. Okay, good. So one of the interesting things about slope is that when I'm going in a positive direction, it's up 2 over 1, up 2 over 1, right? But if I'm going in the other direction, I would go over 1, down 2, over 1, down 2, over 1, down 2. Do you see what I'm saying here?
Yeah.
Right? So you just need to go like over 1, down 2, over 1, down 2, over 1, down 2, and maybe even do it again. And then you'd have a point here and a point here and just get a ruler and draw a line.
Okay.
Yeah. Because with to draw a line all you need is 2 points. In fact, really what you could do is you could just put up a ruler up against this side right here and see where it intersects the y-axis, because it's going to have the same slope everywhere. All right, well, boy, we're learning about slope. That's awesome. That's cool. Okay, so I have the function here, 2x minus 4. And let's see, what is the domain of this piece of the function? Alexis.
Would it be negative or positive 3
Uh-huh.
to infinity?
I think it would be. It would be positive 3 to infinity. And is positive 3 included?
No.
It is not included. So we have just completed our piecewise function. Now, I'm going to make a statement that I think there's a number of you who are kind of getting this, but just really aren't really totally clear. So I'm going to tell you to do some of the practice problems and talk to me before you start the test. All right. I want you to be able to do this. So, you know, kind of practice a little bit. And if you're not getting it, like, hey, send me an email and we'll go over it. No problem. All right. Right. Because I'm seeing faces that are telling me, I'm not so sure about this. Okay, let's find the domain of this function. So I'm going to use the number line to find a domain. So here is a number line. And here is 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, negative 5, positive 5. So my first piece is going from negative infinity to negative 1. So my red piece there, negative infinity, and it's going to stop right here at negative 1. So I'm going all the way here, and I'm going to stop right here at negative 1, and it is not included. And then my next piece, the purple piece, starts at negative 1, is included, and goes all the way to 2, and is included there too. And then my next piece starts at 3, not included, and goes to infinity. So I'm looking at this number line, and I can see, well, my farthest left point on the number line is negative infinity. So I can start there. And I'm going along here, and it ends there at negative 1. But then the next piece starts up again at negative 1 and is including negative 1. So I don't have a gap. Everybody see that? A no gap. No gap. And that goes all the way over here to positive 2. So my first piece is going from negative infinity to positive 2. And then I do have a gap. So I'm going to have to put a union. And then it starts at 3 and goes to infinity. But 3 is not included, and it goes to infinity. That is the domain of this function. Yes, Elena.
Wouldn't the 2 be included? So it would be a bracket?
Yep, it sure would. Fish. You're right, it's a bracket. My bad. Half a point off for Mr. Jenkins. You know. Okay, are you good with that? Now, the range, I'm just going to do it for you because we only have a little bit of time left. But my lowest y value is negative 2. Can everybody see that? That's the lowest y value on this graph. And it doesn't really go up or down right there. It just is at negative 2. So my range is going to start with just simply negative 2. And then I have a gap. I don't have another y value until right here at negative 1. And that is not included. So I have this gap. Negative 1 is not included. And then that is going up to infinity. Now, I know there's it kind of looks like a gap right here, but this isn't really a gap because I have y values over here. So this is going from -1 all the way to infinity because these lines just go up forever. Okay. This is a problem that, where'd it go? I was going to go over, but I decided I just added it as an extra credit problem on the test. So this will be a fun one. I'm sure you'll just have lots of fun with it, but it is only extra credit, and it's a separate PDF on the test. So, any questions?
I have a really quick question for the range. Like, I just get confused because I like understand the -2, but then I don't really get the negative. Like, why? Like, I would think it would be 1.
Oh, you know something? Angie is right. I am wrong. Boy, 2 fishes in a row. That's terrible. Yeah, and you're right. I'm wrong. It isn't -1. I'm looking at, see, and I'm doing the same thing that you guys do. So it's because you look at the x values, right? And the x value is -1, but I'm dealing with the y value. It's not -1. It's positive. Oh, thank you, Angie. You just saved this entire video that I just made here, right? Yeah, it's not -1. It's +1 because the y value is +1. Mr. Jenkin, you are just messing everybody up. Yeah, thank you for that catch. All right, I'd let you do fish, but it's only 2 minutes and that will take too much time. So, are we good? Are we good? All right, do some problems, ask me questions. All right, we'll catch you later.
Thank you.
You're welcome. Isa, got a question for me?